So I'd like to try this problem here, but before we get there, a quick FYI. If the discussion is to find dy dx, then for something like, let's say, 20x cubed, the derivative of that, if we're talking dy dx, the derivative here would just be 60x squared. However, what if I have 20y cubed? If we're talking about dy dx of this, it would be 60y squared, but then you attach a dy dx. So that's if the discussion is dy dx, which it usually is. So for instance, another one, how about like 5x to the fourth? The derivative of that would be 20x to the third, as opposed to something that said 5y to the fourth. That would be 20y to the third with a dy dx attached. That's just what we do. Later on, we can discuss why. So let's go back here. And the goal here is to find dy dx. So let's go term by term differentiation. So the derivative there would be 42x to the sixth. Take away. Now, the derivative of natural log, what you do to that thingy is you reciprocate it. But then you multiply by the derivative of that thingy, which is 5y to the fourth times dy dx, because you're dealing with y's. Plus, now the derivative here would be 12y to the first times dy dx. And the derivative here would be, this was a 52, 13 times 4 is 40 plus 12, which is 52, x to the third, and there's no dy dx there. So now the goal is to isolate dy dx. So anything that has a dy dx, I leave it on this side. Anything without, I move it to the other side. So I have this term here, which I'll move over there. This is one giant term, which is going to stay. And this is another big term, which is going to stay. So I have, this is what I have. Check it out. I have negative 5y to the fourth over y to the fifth dy dx plus 12y dy dx equals 52x to the third minus 42x to the sixth. And let's see, so I can simplify this. That'd be negative 5 over y to the fifth dy dx plus 12y dy dx. So a lot of little baby algebra. And that's an x right there. That's an x minus 42x to the sixth. Now the next part is the key part. The reason you want to leave dy dx on the left is so that you can have the opportunity to factor it out to the front as a GCF. And I have this here. Now the final step is to isolate dy dx. So I'm going to divide both sides by this stuff there. Negative 5 over y to the fifth plus 12y, like that. Negative 5 over y to the fifth plus 12y. And of course, these are gone. And so dy dx has been isolated. I'll put it there, and it equals this. Now, can this expression be simplified? Yes, it can. Do they want you to do that? I don't know. But if they do, then please let me know, and we'll see what's up. So I made up a problem that looks like yours. Try yours. And if you get what they want, good. But if not, then I'll show you how to simplify something like this. But there you have it. That's how you find dy dx for an equation that looks like this.